chords equidistant from a center of a circle are equal in length. Okay, so let's prove it off. Actually, I want you guys to pause. Try to draw the diagram, just have an idea. If you get the diagram, then the proof is not that difficult. Draw the diagram, write the given, that is, describe the diagram, and end of it, write what is that we need to prove. I hope you guys tried it. So we are looking at a chord, not that, a chord, right, and one more chord. So if this is the center and we have a perpendicular line and another perpendicular line. Okay, so here they have given that these two lines are of equal length. So let me name them. Let me use this AB, and this is PQ, and let me call this as T, and let me call this as E. These two are your perpendicular lengths and they are equal. We need to prove that PQ is equal to AB. Okay, so let me describe the diagram. Let's consider a circle with center O. Let AB and PQ be two chords. Then let OT and OE be two perpendicular lengths from the center of the circle to the chords OT, right, PQ and AE respectively. Okay, I hope it makes sense. Now it's given that OT is equal to OE, right, and we have to prove PQ is equal to AB. This is what the theorem talks about. So if all this condition is satisfied, then this is true. Now how do you prove it? So I'll give you guys a clue. Join OQ and AB. That's your clue. Now let's start with, let's consider triangle OTQ and triangle OEB. Here we have OT is equal to OE. This is given. And we have OQ is equal to OB. They are your radiuses. And we have what? And we have OEB angle is equal to angle OTQ. Both of them are equal to 90 degree. Okay, since OT is perpendicular to PQ and OE is perpendicular to AB, right? So this is, with this, what can we conclude? Therefore, by RHS congruency, is that correct? Right angle, and we have a hypotenuse, and we have a side. Triangle OTQ is equal to triangle OEB. So what does this imply? This implies EB is equal to PQ. Okay, so this length is equal to this length. We're almost done. So the next step is, oh yeah, I forgot, CP/CT. The next step is multiplying with 2, multiplying 2 both sides. So what will we get? We'll end up with 2EB is equal to 2PQ. How will this help? Well, 2 times EB is AB and 2 times of PQ is, sorry, not PQ, TP, my bad. TP is PQ. Okay, so why is it so? Because a perpendicular line bisects, right? I hope, oh yeah, I need to, I had to write that statement over here also. No, I need to write it over here. A perpendicular from the center of a circle to a chord bisects the chord, right? Because this gets bisected by the perpendicular lines, so double of this will give you the entire thing. So since this is x, this also will be x, so this entire thing is 2x. Since this is x, this also will be 2x, so this entire thing will be, sorry, if this is x, this also will be x. If this is x, this also will be x. This is also x because, well, this is what we proved, and this is also x. As a whole, this entire length is 2x and this entire length is 2x. And we have hence proved. So that's your proof.